Okay, the last two sections of Chapter 11 is going to deal with properties of liquids and vapor pressure. Okay, so the first thing we're going to talk about is properties of liquids. We're just going to talk about two. We're going to talk about viscosity and surface tension. Okay, so viscosity deals with the resistance of a liquid to flow. Okay, so let's talk about this for a second. So if a molecule has a high viscosity, that means that it's going to resist flowing. So one of the examples that I always think of is asphalt. Okay, if you've ever seen asphalt laid before, it takes forever to come out of that machine and then to go onto the ground. Okay, so I always say that these molecules don't want to move. Okay, so viscosity deals with how molecules move with respect to each other. Okay, so if they have high intermolecular forces, meaning they're interacting with each other strongly, their viscosity is also going to be high. Okay, so let's look at some things here. So viscosity will increase with molecular weight and decrease with increasing temperature. Why do we think this is? Well, if we're increasing molecular weight, we're also increasing the intermolecular forces between those molecules. Remember, because force equals mass times acceleration. So our force will increase if the mass of the substance will also increase. But why does it decrease with increasing temperature? Okay, well, hopefully when you hear temperature or increasing temperature, you should be thinking about more movement. Okay, so if the molecules have more movement because you have a higher temperature, that means they're not going to have strong intermolecular forces. Okay, so if they don't have strong intermolecular forces, they're going to be able to flow very easily. Okay, the second property of liquids that we need to talk about is surface tension. Okay, so surface tension is the force felt by molecules at the top of a liquid due to strong forces underneath. Okay, so let's get a working definition down for that. So the example that I always give here is water has really high surface tension. Okay, so if you've ever seen that movie Ants before, where that little ant gets stuck in the water and it can't push itself out, that's because water has really strong surface tension. And basically what that means is the water molecules underneath the top layer of the surface, okay, their interactions are so strong that it's basically like forming a little bubble up at the top. Okay, so the forces below are actually pulling down on the forces on the top, and it makes the surface really, really strong. Okay, the last two things that we're going to talk about are cohesive forces and adhesive forces. Okay, so cohesive forces are attraction of similar molecules. So that would mean that the molecules are more attracted to each other than anything else. And then adhesive forces is the attraction of the molecule to a surface, okay? So if we look at this, okay, convex versus concave, okay, this is the meniscus that you usually see with water, okay? Why? Because water actually has really strong adhesive forces to the side of the container, okay? And that's kind of why you see it sticking up at the top, where down here, these molecules have a really strong force for each other, so they're pulling, and that's why you see your little concave there, okay? Where if you have a convex, that means that you have more cohesive forces, okay? Okay, so that is section 11.3. The last section for chapter 11 that I'm going to talk about is section 11.5, which is vapor pressure, okay? So vapor, you have to remember, is a liquid at room temperature, but when you apply energy, it turns into a gas, okay? So it's not gas under standard conditions. It's a liquid under standard conditions. So vapor pressure is when a gas and a liquid stabilize, the amount of pressure exhibited by the gas, and the gas will also stabilize. Okay, so for example, Currently, in this Erlenmeyer flask, I just have liquid, okay? If I were to apply pressure or heat, okay, and it turns into a gas, okay, once the liquid and the gas are stabilized, the increased pressure, because remember I'm going to have increased pressure when I have gas because the molecules are hitting the size of the container more, the increased pressure is going to be the vapor pressure once it's equal, okay, meaning I'm no longer forming gas molecules, I'm no longer forming liquid molecules, okay? It has to come to equilibrium, and that's going to be vapor pressure. Vapor pressure is going to deal directly with intermolecular forces within the compound, okay? If the liquid has really strong intermolecular forces, you're not going to have high vapor pressure because the molecule won't want to turn into a gas. Where if it has very weak intermolecular forces, it will easily turn into a gas because the interaction between the molecules is not as strong. Okay? Thanks, guys.